Math is a wonderful thing. Math is a really cool thing. So get off your act, let's do some math. Math, 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 math.
We're going to be still talking about simplifying rational expressions, except instead of just finding a common monomial factor, instead of just a greatest common factor, we're going to be looking at binomial factors. Okay, so we're going to have to be factoring some quadratics here. Using all of these, we will, most of them are going to be X method factoring. Very, very simple. Again, if you need a review on factoring quadratics, you're going to have to go into Khan Academy, or, you can just email me and let me know, and I can give you a link to some examples for that. All right, so directions are still the same. Simplify the following rational expression, and then tell me what makes this undefined. Okay, so remember when we're talking about things being undefined, we're looking at the denominator. All right. Step 1, we still have a red expression and a blue expression. Just simplify them separately. Don't even worry about the fact that it's set up as a fraction. Okay, so for the red one, what multiplies to give me 6 and adds to get me 5? Well, x plus 2 and x plus 3, right? 2 times 3 is 6 and 2 plus 3 is 5. The order does not matter. All right, just the signs matter. You could have said x plus 3 and then x plus 2. Now in the denominator, we need to think of two numbers that multiply to give me 12 and add to get me 7. Well, that's 3 and 4, right? 3 times 4 is 12, 3 plus 4 is 7. All right, when you get to this part right here, this is where we can start canceling things out. So what things do they have in common? Oh, x plus 3 and x plus 3. They don't have to be right over each other, okay? They just, one has to be in the numerator, one in the denominator. So this becomes x plus 2 divided by x plus 4. This is as simplified as this gets, okay? I know a lot of us want to go x over x cancels. It doesn't work like that because of the plus signs, okay? If it was x times 2 and x times 4, then yes, but it's not like that. All right, let's talk about domain restrictions. Remember, we look at the bottom, the denominator, but let's go ahead and check this part out. This is where we want to go. I just set everything equal to 0, so x plus 3, I want to figure out, well, I set it not equal to 0. I want to figure out what x has to be for this to not be 0, or to be 0, because x is not allowed to equal 0. Subtract 3 from both sides here. So x cannot equal -3. And x cannot equal -4. Those are my two. It can be anything else, literally any other number. It just can't be those two. Okay, even though when I look over here, I can plug in -3 and it'd be fine. However, whenever we're plugging things in to evaluate, we always go back to the beginning, the very beginning, okay? And if I plug in -3, it won't work. Next problem. All right. A little bit different factoring here. Now the numerator, you might not recognize it right away, but it is a difference of 2 squares. Which means it's going to be the same thing in both terms, just one's positive, one's negative, and you take the square root. The square root of x squared is x. I want this in red. And the square root of 121 is 11. This only works if they're perfect squares. All right. Now that was the numerator. Now the denominator, regular x method. What multiplies to give me 55 and adds to get me 16? 11 and 5, both positive. Now, do we have something that we can cancel out? Yes, x plus 11, gone. What's left? X minus 11 over x plus 5. Now let's look at our domain restrictions. So, just to make this simple, all right. Now, this one is a little slightly bit more complicated, but the idea here is the same. All right, I'm just gonna factor. Now look at this. I have a number in the front, that's a 6. Okay, I should just check to see if it's a greatest common factor. And if it is, then we wanna factor that out and kind of keep factoring along with it. Okay, so if I take a 6 out, what's left? X squared plus 24x plus, I have to divide everything by 6, so don't do what I just did. X squared plus 4x plus 3. And my denominator, well, we can factor this using the x method. What multiplies to give me negative 18 and adds to get me negative 3. Well, one's positive and one's negative. In this case, the bigger number is going to be negative, so it's going to be 6 and positive 3. Negative 6 and positive 3. Okay, let's go back to this numerator. I'm done factoring the denominator. This numerator is not quite finished yet, even though it looks like it. I can also split this up into 2 binomials. Well, multiplies to give me 3 and adds to get me 4. Positive 1 and positive 3. Divide it by, just rewrite your denominator. See who cancels out. Oh, x plus 3, x plus 3. Anything else? No? Okay. So I have 6 times x plus 1, all divided by x minus 6. Now this is an acceptable answer. Sometimes people will distribute this back in because since it can't be canceled out, I'm not sure how Khan Academy will feel about that. So these are equal. Okay, so to me it doesn't, I personally would prefer this one. I do not know if Khan Academy feels the same way. All right, now let's talk about domain restrictions. Again, denominator only. The numerator does not affect the domain at all, okay? So don't ever set anything in the numerator equal to 0 to solve for x, only in the denominator. So x plus 3 can't equal 0. X minus 6 can't equal 0. I'm just doing opposite. So negative 3, positive 6 are my domain restrictions here. All right, guys, let me know if you have any more questions. Good luck.